Hi, this is our team presentation for Lesson 8 for course CIT 260-08. Our instructor is Brother DeBry. My name is Jason Chantry.
My name's Ken Strobel.
We'd like to first go over the 7 functional development process, 7 steps of the functional development process.
Right. Step 1, clearly define the problem. Step 2, create the test matrix. Step 3, outline the solution. 4, test the algorithm. 5, translate the algorithm. 6, run the test cases to verify that the code is working as specified. And step 7, deploy the changes to your repository.
So step 1, clearly define the problem. Together as a team, we created a development document to gather the information for each step in the fundamental development process for the by land method in the crop control class. So first we wrote defining the problem that we recall that a bushel of wheat in the currency is the currency for our game. The price of land is a random value generated by the game. Suppose that the land price is P bushels per acre. If the player elects to buy N acres of land, then the program must do the following calculations, where S is the total amount of wheat we own and A is the total number of acres we own. So we say S equals S minus P times N is our formula, and so we need to integrate that into our code.
Yep. So then we create what is called a test matrix. The test matrix is just something so we can visually see how that information we just wrote down kind of goes into play. So we have our inputs, which is this section here, our acres to buy, land price, acres to own, wheat in store. And up here, we use the test matrix to find out and determine which of these calculations work. Valid would be a valid price. You have acres to buy is 10, land price is 20, acres owned is 2,800, wheat in store is 4,000. So you just purchased 10 acres, your return value is 2,810 now, so you just bought 10, and your wheat in store is now 3,800. So using that same math formula, we make invalid cases now. So if you wanted to buy -5, which you can't buy a negative number, or too much wheat, it would return a -1 value, which means invalid. And here is boundary cases. So in the test matrix, you would configure this table to show the limit of how much you could buy with your wheat in store. And of course, the boundary at the opposite end as well. And that's a test matrix.
Cool. So step 3 is outline the solution. So basically, we take what our problem was and we create a solution. So the purpose of this, our summary section tells us that the purpose of this function or method is to buy land. The parameters, these are input parameters coming into the method, is the price of land and the number of acres to sell. And the method will return the amount of land after the purchase. Preconditions are the number of acres to be bought must be greater than or equal to 0, and the cost of the number of acres we want to buy must be less than or equal to the wheat in the store. We then take that and turn it into what's called a method prologue. This basically goes over our summary and our preconditions, parameters, and all that, and we put that into our code so that we can see exactly what this is going to do. And then we create our method signature. So down here, this is a public function. We're going to return an integer. A method name is by land, and we have 2 variables that we're looking at importing from whatever method is calling this function. The first is going to be named price in our function, and it's going to be declared as an integer. And the second is acres to buy, and it will also be declared as an integer. Excuse me. So then we have the test algorithm. This is the algorithm that we call pseudocode, which is how do we get with our problem, how do we actually, what's the formula or algorithm we're going to use in order to get the correct return value. So as Ken was talking about our test matrix, we can actually take this test matrix and plug in numbers. So if we say, like for instance, I'll just give you an example, valid argument here, or test case, acres to buy would be 10. So anywhere there's an acres to buy, we put a number 10 in there. Land price, 20. Acres owned, which is here, 2,800. And wheat in stores, 4,000. And if we run all of that on paper and get out our calculator, we have a return value of 2810. And so that's exactly what we're showing here. So we know that, okay, in that case, our algorithm works. We then go do the same thing for our invalid and our boundary test cases.
Perfect. And next we would go to step 5, which is translate the algorithm into code. And so this is where we would take that test matrix information that we were just running, and we would use the algorithm to use this pseudocode at the top here and make pseudocode. So we would say the integer wheat in store equals crop data get wheat in store. And then we do the same thing for acres owned. So we would start plugging that data in to each one of these sections here.
So that's where we actually initialize those variables. And that's the interesting thing. So we initialize, this is an integer, this value, and we're pulling in an instance of crop data, and we're calling that method get wheat in store. That's where we read it in. So that allows us to take whatever that value is and assign it to that variable. So,
yep. Perfect.
So go ahead.
No, sorry, you go ahead. That's fine.
Acres to buy. So then we take our pseudocode. If our acres to buy is less than 0, we want to return a value of -1. So we write an if statement. If acres to buy is less than 0, then if that is true, then it executes the code within these curly braces, and so we return a -1.
Yep, perfect. And the next if statement would be if acres to buy times the land price is greater than the wheat we have in store, also return a -1, because we don't have enough money or enough wheat to buy land.
Right. And it's important to note here that we have to, just like in any order of operations, we've got to do our little parentheses. So we want the program to do acres to buy times price first, and then compare that value to wheat in store. So acres owned equals acres owned plus acres to buy. And when we write that in code, we could write acres owned equals acres owned plus acres to buy, but we have this nice plus equals operand here that we can use, so that will automatically add acres to buy to acres owned, and then we set the acres owned variable inside of crop data to what we've calculated.
Right. So then you have additional acres owned, and we would do the same thing for wheat in store. So wheat in store would be less than or equal to acres to buy times the price. And so then you would set your new wheat in store value to whatever it is minus your newly purchased land.
Sweet. And then the very last thing, we return back to the calling function returned acres owned, because that's what we're supposed to, or what our design specification document says that we should do, and that's what we're doing. So step 6 is return the test cases to verify that the code is working as specified. So here is where we've already done our test matrix, which is on paper. We make sure that our algorithm works properly. We then just did all of our coding in our method, so we know that that algorithm is now in code form. And so now we're going to go to, we create a crop control test class, and we put in our test code. So just to show an example here of, we have a valid, we have actually 8 test cases here, so we have a broader range of different, entries that could be done. So we have valid, first of all, here in our test by land, we print by land case 1, just so we know that we're now executing this code, and that goes to the console. We create a new instance of crop data and assign it to the crops, that's variable. So then we say the crops, which is referring to crop data, set wheat and store to 1,000. And then set the crops, set acres owned to 500. And just realized that we have the wrong test case here, but I believe. But anyway, it's the same thing. Anyway, integer. So we declare this price variable as an integer. We equal 10. Oh, that's we're just setting up. Yeah,
yeah.
We're good. So price equals 10. The acres to buy equals 50. Yeah, we do have the wrong thing there. But the expected result of this would be 550. And right. So then we say the result equals crop control dot by land. So we're calling that function. And we pass it price, acres to buy, and we pass it our instance of crop data. And then we can compare. The test module here wants to look at this assert equals. So if the expected result equals the result, then we give a thumbs up. We're good. We get 100% on that one. So apologize for the incorrect picture there. 10.101. So yeah. So here we actually show all of the different test cases for each of these. So if we plug in, and this one's actually correct. I just got the wrong test case there, but before. So case 1, this just shows basically what the computer is doing. We plug in these numbers. It results a 2810, which is going to give us, the thumbs up. And if all of these come out are equal to what the expected result that we put, down here, wherever that expected result is, then we'll get a thumbs up and everything will be great.
Mm-hmm. Perfect. And then, of course, the last step is after you successfully tested all your test cases and the code is ready to be added. And, well, if there's no broken or flawed code, it shouldn't be pushed. But let's just say it is, and it's been tested and it's error-free. Then you can push or upload that to your online repository. And those are the 7 steps.
Excellent. So then we have variables, our variable lifespan. So we'll talk about that a little bit. The variable lifespan is dependent on what type of variable we're using and where they're located. If it's within a class statement, if it's within a method, if it's within a if statement, they all have different lifespans. First one we're going to talk about is a class instance variable. These variables are written inside a class and are made up of a private modifier and a public getter and setter methods. These variables are read and set by creating an instance of them and then referring to that instance to set or get the value contained in the variable. So here we have an example from our code of a private modifier. Basically, we're initializing acres owned as an integer, and it's set to private. The getter method and setter methods are here. This is what other methods can call to either read what's in here or to set this variable. So public integer means that our get acres owned is an integer, and when this is called, then we're going to return acres owned. So we're going to return what this variable contains, the value of it. When we set it, so if we have a number that we want to set this to, we would call this function, and we're returning nothing. The name of this method is set acres owned, and we're looking at reading in what the calling method is giving us, and we're assigning that to acres owned. So we're saying that this instance acres owned equals what the other method has given us. We can create an instance of a variable by saying, like, for instance, all of this is contained in crop data. So we say the crop data class, and we're putting a variable here, crop data, with a lower c so that they can be distinguished, is equal to a new instance of crop data, the crop data class. So to get a value, we would say this is our new variable. It's going to be an integer. We say it's equal to crop data, which is an instance of the crop data class, and we're going to call get acres owned, which is right up here. When we do that, we'll be able to get the value that's contained there. To set the value, again, crop data, we set acres owned, and we give it the value we want to set it to. So the lifespan, this variable lasts as long as there's an instance of the variable in use. Effectively, these will potentially last until the program ends or the last reference or instance is closed.
Right. So the variable lifespan, as he mentioned, can be passed from one method to another, and that's done by putting the variables and types inside the function signature. So here is our function signature right here, and we can add variables into here inside these other parentheses here. So the variable named price is defined as an integer, and the variable named acres to buy, also an integer, and we're bringing in a new instance of crop data. And so when this function is called, we can pass two variables to it. The variables will be called price and acres to buy. And so it will look something like this. Int variable return for value from function equals crop control by land is, and then these are what's being called in, 10, 100, and the crop data. So the 10 is passed to the price variable, so from here to here. And the 100 is passed to the acres to buy variable, so acres to buy is 100. Thus, inside the buy land function, price equals 10 and acres to buy is 100. So the lifespan of the variable lasts until as long as the method is running or the variables expire. So between these other curly braces, and when you find the opposite one facing the opposite way, that's when it'll end. So usually within this function signature, that's when it will end.
Awesome. And that integer, the price, and integers equal to, acres to buy are examples of passing a variable by value. So we're passing the value of these over to the function we're calling. Crop data and crop data, so this is the instance of crop data we're assigning to this variable, is an example of passing by a reference. So we pass here, if we set a new instance of crop data to the crop data, and then we say we want to set a temporary variable, which contains the returned value, and we call the by land method. We pass 10, 100, and the crop data. So the 10, 100, or if we put actual values in there, or if we put actual variable names in there, we're passing that by value. And then the crop data, we're passing this instance of crop data that we're using, that's passing by reference over to the function that we're calling.
So instant variables are data members. So these variables are used inside a class or method in a class for reference in the entire class, or just inside the method there defined respectively. So private int acres to buy, private int offering, acres to buy is 50. So if these variables are placed inside the class, their lifespan is from when the class is called until the class is closed. So once again, it's usually between these curly braces. So when this starts, that starts the lifespan, and when it ends the lifespan. So if these
And
variables, oops, go
that's
ahead.
one thing, Ken, I was thinking too is that anytime, so throughout like the program that we're writing, this game, City of Erin, anytime crop data, there's a lot of references to crop data.
Mm-hmm.
Anytime that if there's a hold or an instance of crop data open, all of those variables stay live.
Mm-hmm.
So really, in our case, crop data is only, all of those variables are going to expire when we close the program, right? So that's
Yeah.
Or we start a new game and it ends everything. But yeah.
Yeah, exactly. Exactly. That's perfect. Yeah. So if the variables are defined as an if statement, the lifespan is from the if statement and lasts until the end of the if statement. So that's kind of, you can define the lifespan of each variable depending on how long you want it to last, or if you want it to last a little bit longer. It kind of all depends on if you're using an if statement or just the curly brace.
Perfect. So I want to talk a little bit about some of the code that I wrote, some selection statements. Selection statements are switch and if are two examples of selection statements. So I'm showing here if someone wants to pull up the repository that we have, you can show lines and help menu view class 96 through 114. So we show here we have a switch, then case and breaks. Switch use the option which is passed by the calling method, which contains the user input from 1 to 6. We already gather that. We pass it to this switch function, and if option is equal to a 1, it's going to do case 1. And case 1, the code follows this statement for the first selection. Case 2 is for the second input that the user gives, and for each if they enter 1, 2, 3, 4, 5, it will call or execute this code until the next case statement. So what we do is if we have a number 2, we display help where we're going to call that method. We don't want it to go continue evaluating because we already know we're here. So we say break, and what break does is actually exits this switch statement here. In the crop control class and the pay offering method, I used an if selection method. I've used several of them, but this is just one example. So the if statement is used to evaluate a condition and execute the code within the curly braces if the condition is true. So the code to the left says if the value of percent offering is greater than 0, then execute the following inside this curly brace. So here we have the amount of wheat for tithes equals the value of harvest, which is set up here. And then we times that by our percentage. Now our percentage coming in from the user, they might type in 12%, 1, 2. We need to divide that by 100, which will give us 0.12, so we can actually get the percentage. So test cases code, some of the test cases I did in the crop control test class. The method I'm going to talk about is feed people. So we have a test feed people method inside of that class. So first, it's important to have tested the algorithm I created by using the test matrix before coding. Once the algorithm worked on paper by running through all the test matrix cases, I coded the feed people method, which took my pseudocode, turned it into actual code. Then to test the feed people method, I created the code to test each case in my test cases table. So here is an example of the code for the first test case. So here we say, once again, like I talked about before, we're just going to print on the console screen, feed people test case 1, so we know that we're starting that. Crop data, this creates a new instance of crop data, assigns it to the crops. So then we're saying the crops, we're going to set the wheat in store inside of the crops to 2,000, which is set here. The amount to feed people, we're going to set that to 500, which is here, our test case. And then our expected result is going to be 1,500. So we're initializing those variables as integers and assigning them a value. Integer result, this result is going to be the return value we get from the feed people method. And we're sending it the amount to feed people, which is going to be 500, and we're sending it our instance of the crops, or crop data, excuse me. Then our assert equals, again, we evaluate what the expected result is and what the actual result is after running the method and feeding it all this information. If it's true, then we get a test passed. If it's false, we get a 0. And then it starts going through. Here's the some of the code. Do the first case, the second case. As you can see, we don't have to initialize the variables again because they're already done up here. So we can just reassign them. So we have wheat in stores 1,500, which is the same here. Amount to feed people 750. Our expected result is 750. And so on and so forth. So we have all of these cases all the way through case 8. And if it runs all of those and they all give the expected result, we get 100%.
Perfect. I did a similar thing as Jason did, obviously, as part of the course, is I did the game menu view Java class, and just like he did, we used switch options. That way, if someone hits option 1, it goes here, and then it ends, so it won't continue on processing in this more code. That's what the break is. So I did a similar thing to him, but I only had 5 instead of 6 options. Here's another one of the codes I did in crop control. It's a harvest crops method. This was a little bit tricky. This is the first one I did, and we weren't taught how to do random yet, but we got it figured out with if statements. So the if statements for randomness have to do with tithes paid. So if tithes paid is greater than 12, we pick a random number between 2 and 4. Same thing with tithes paid are less than 8, it's 1 to 3. Greater than or equal to 9, and less than or equal to 12, it's 2 to 3. So keeping that, yeah.
Is that that's the basis? So we're starting at 2 and we're going up 3, right? So 2.
Yeah, exactly.
2 to 5 is essentially.
Yeah, okay. Exactly. So basically, well, keeping that in mind, the base and the range in this test case, if you have these in your test cases, acres planted 20, let's say your tithes paid was 12, and your crop yield would be a random number, let's say 5. And so the wheat to harvest would be 20. So or wheat to harvest would be 100. Therefore, because you had 12 tithes paid, you got 5 as a random number, and then you return 2,100 wheat in store. So that's the code that we used for my harvest crops. The random part was the only tricky thing, but otherwise it's similar to what Jason was talking about. But this shows a little bit more of the example I was talking about. So if we had 20 acres planted, it would say the crops set acres planted to 20. We have 2,000 wheat in store. We have 12 offerings, which is tithes paid. And so just as he was saying, the expected result would be 100 if the crop yield obviously is 5. And so the result should be 100. And if that's the case, we'll get a nice true statement. And here's some of the code I used, similar to Jason. We had initialized this, and we told the crop yield, if the crop yield had a random number of 2, the expected result would be 40. If it had a random number of 3, it would be 60. So we defined each possibility in the random code. And
Ken, I like what you did there because, this is actually more thorough than just forcing the crop yield of what you had over here, 5, because you
Yeah,
can run the test many times, and for every random number it can generate, you have an expected result. So,
exactly. Yeah, and so it becomes back as true or tested positive each time. So
right.
that's perfect. Here's just the other cases for my boundaries as well. So, yeah, that's the last part of the harvest crops. Um, back over to you, Jason.
So thanks for spending some time with us for our team presentation, and have a good evening or afternoon.
Yeah, thanks. Bye.